Ever wonder how your phone or computer can solve a Rubik's Cube in seconds? It's not magic, it's math, and a whole lot of clever coding. Today, we're breaking down a groundbreaking study that's making search algorithms way faster by teaming up two types of computer processors, CPUs and GPUs. Let's dive in. Imagine you're trying to solve a maze. A classic algorithm called AIDA, iterative deepening A, works like this. It explores one path at a time, checking if it leads to the exit. If it hits a dead end, it backtracks and tries a different route. But here's the problem. This brute force approach can be super slow, especially for huge mazes or puzzles. It's like searching for a needle in a haystack by checking one straw at a time. Enter GPUs, those powerful chips you know from gaming. They're built to handle millions of tasks at once, like a factory with thousands of workers. But here's the twist. Traditional search algorithms weren't designed to use GPUs. They're more like a single worker on an assembly line, not a team of specialists. That's where this new research steps in. The breakthrough. A technique called CB-DFS, cost-bounded depth-first search. Think of it as a relay race. The CPU acts as the strategist, mapping out the best routes, while the GPU is the sprinter, crunching numbers in parallel. Here's how it works. The CPU sends promising paths to the GPU, which evaluates them all at once using a neural network, a kind of smart shortcut that predicts the best moves. It's like having a GPS that not only shows you the way, but also tells you which roads are least likely to be closed. But wait, how do they make sure the answer is still perfect? The key is balancing speed with precision. The researchers proved their method doesn't skip any critical steps. They tested it on puzzles like the Rubik's Cube and 4x4 sliding tiles, and the results? Mind-blowing. With GPUs handling the heavy lifting, the algorithm solved puzzles up to 30 times faster than older methods. And the best part? It still finds the optimal solution, not just a quick fix. What's really cool is how they tackled a big challenge, making neural networks work with traditional search algorithms. By using techniques like quantile-based classification, think of it as sorting paths by likelihood of success, and ensemble networks, like a team of AI models voting on the best move, they kept the estimates accurate. No more guessing wrong turns. But there's more to this story. Researchers also explored two competing approaches, Batch IDA and AIDA. Both aim to speed up search by processing multiple paths at once, but they take different shortcuts. AIDA relies on pattern databases, pre-written cheat codes that remember common maze layouts. It's super efficient if those codes match the problem you're facing. Batch IDA, though, uses neural networks, which are like smart assistants learning on the fly. They don't rely on pre-made answers. Instead, they figure out the best path as they go. Here's the catch. When you batch processes, like sending a whole stack of maze problems to a GPU, the computer's muscle, there's a hidden speed bump. Transferring all that data between the CPU, the brain, and GPU is like trying to fill a bucket with a garden hose that's too narrow. The bigger the batch, the more this bottleneck slows things down. So how do researchers fix this? They tweak two things, making the neural networks hints smarter and speeding up that data transfer. It's like training a better assistant, who gives you clearer directions and upgrading the hose to pour water faster. But here's the twist, hardware matters. The study tested everything from mid-range to top-tier systems. AIDA worked best on powerful hardware, like a race car that needs a perfect track to shine. Batch IDA, though, was more consistent, like a reliable teammate that adapts to any setup. The real winners. A top-tier GPU and CPU working together. Think of it as a dream team for problem-solving. This isn't just about faster code. It's about understanding how to balance speed, smart tools, and the limits of our machines. Whether you're navigating a maze or training an AI, the lesson is the same. Progress isn't just about building faster tools, it's about knowing when and how to use them. Next time you see a puzzle solved in seconds, remember, it's not just luck. It's a team of processors working in harmony, powered by science. Thanks for watching, stay curious, and I'll catch you in the next video.